It's been a little while since we looked at this now. It's Tuesday. Yesterday we did an activity. Friday we looked at this for the first time, this concept of acceleration. Up until that point, all of the problems that we had done involved constant velocity. Velocity that's not changing, an object that's moving the same distance in the same amount of time. Now we're talking about acceleration, the rate of change of velocity, not how fast something's moving, but rather how quickly it's accelerating. Something can be accelerating at a very high rate, but yet moving very slow. Something can be accelerating at a very small rate, but yet moving very fast. So acceleration is not the same as velocity, but it's related in the sense that it's the rate of change of velocity. What's the main equation that we're going to use for acceleration based on that definition? Devin? Oh, your hand wasn't up? Oh, well, that'll teach you for stretching then. What's the main equation that we use for acceleration, Devin? I'm sorry? What's the main equation that we use for acceleration? Yeah, okay. Or just delta V over delta T. So the acceleration is delta V over delta T. The rate of change of velocity. Anything that's a rate has time on the bottom. And then, of course, if it's a rate of change of velocity, it's going to have change of velocity on the top. What units are we going to use for acceleration? Velocity is meters per second, right? Time is seconds. We could say meters per second, that's fine. But the typical way that we express that is meters per second squared. Is acceleration a vector or a scalar? Does direction matter or not? If it depends upon velocity, is velocity a vector or a scalar? Vector. So is acceleration a vector or a scalar? Yeah, it's a vector as well. Good. Acceleration is a vector. Direction does matter. You accelerate to the right or you accelerate to the left. There's a difference. Okay, if I want to drive to Lethbridge, I need to know which way I'm accelerating in my car, not just a scalar version of acceleration, not just how quickly I'm accelerating. Okay, we need to know what direction is, so therefore it's going to be a vector quantity. There were some other equations, by the way, that you're also allowed to use for acceleration. Okay, you don't need to memorize these equations, but on your data sheet, take a look at your data sheet now and give me one of those equations on your data sheet that is valid whenever we have a problem involving acceleration. I don't care what order you give them to me in, just give me one that is valid for acceleration problems. John, what's one of them? Besides delta V over delta T. Okay, so D is equal to VIT plus 1/2 AT squared. I'll finish your thought there because I know that if you start that equation, you know which one you're talking about, right? So D is equal to VIT plus 1/2 AT squared. Okay, it appears in the top of your data sheet, and it is valid every time you have acceleration. Give me another one. Tell me what another one is, please. Jazzy, what's another? Oh, you don't have your data sheet out there? Why don't you grab that data sheet? Okay, you can give it to me anyways. What is it? Good. VI squared. Good. What does VF stand for in that case? Final what? No, not final velocity. What does VF stand for there? We talked about that on Friday a little bit, right? VF stands for final speed, right? There's no vector sign over it. Okay, when we solve for that VF, we're not going to get the direction. We're only going to get the magnitude of it. In other words, we're only going to get the speed. What other equation am I allowed to use for acceleration now? There's a couple more. We got three of them. Delta V over delta T, VIT plus 1/2 AT squared, VF squared is equal to VI squared plus 2AD. There's another one that looks a lot like that second one that we have written down. D is equal to VFT minus 1/2 AT squared. And then we've got this last one that's kind of odd, because although it involves acceleration, we don't even see the term acceleration in there anywhere. VI plus VF over 2 times time. These are what we call group B equations. Okay, group B equations are valid whenever we have acceleration, whenever an object is speeding up or slowing down. There is, however, an equation that's valid for non-group B problems. It's valid when the car or the object is not accelerating, when the object is moving at a constant velocity. What's the one equation that we're allowed to use when the object is not accelerating? This is the easy one, right? Quinn, what's the equation that we use when it's not accelerating, when it's going at a constant velocity? Somebody help him out there. Get up. Good. V is equal to delta D over delta T. Okay, so we're going to circle that in red because it does appear on our data sheet, but it's valid in a different situation, right? Group A, constant velocity. Group B, acceleration. So we should be able to cover every problem that we see now, right? Okay, if it's accelerating, we use group B. If it's not accelerating, we use group A. Well, it's either got to be accelerating or not accelerating, one of the two. So between these 6 equations that we have written up on the board right now, what we learned on Friday and what we learned on the first day of class, we should be able to handle anything that gets thrown our way now. All right, we had 2 questions for homework on page 47. Were there any issues with either of those 2 questions? No? Going once, going twice? Okay, let's take a look at another example then. 1.13 on page 48. This one says a cattle train traveling west at 16 meters per second is brought to rest in 8 seconds. What's the displacement of the cattle train while it's coming to a stop? Remember what we said? Okay, when we read these questions, we've got to take a step back and look at the whole question. Look at the big picture. Don't just write down your givens. That's really important to write down those givens. But it's even more important to look at the question. Don't get tunnel vision on just the givens here. What do we have going on in this question? Does it involve a group A equation or a group B equation? Does it involve constant velocity or does it involve acceleration? Either speeding up or slowing down. Kate, what's the answer to that question? Group A, group B, constant velocity or acceleration? Okay, is it moving at a constant velocity? The cattle train is traveling 16 meters per second and then it stops. Is that a constant velocity? What's happening to this cattle train? To go from 16 meters per second to nothing, it must do what? It must slow down or it must decelerate. So what kind of a problem is it, group A or group B? Yeah? It's a group B problem, right? So that means that we're allowed to use any of those 5 group B equations that we identified just a few minutes ago. We're not allowed to use my group A equation. We're not allowed to use delta D over delta T. Now let's identify the givens now that we know it's a group B problem. Let's define west as positive because everything is going to the west. Something is 16.0 meters per second. Can anybody tell me what that is? It's a V, right? It's a velocity. I'll tell you that much. But is it a VI or a VF? Is it what the object is moving at the beginning of the problem or at the end of the problem? We know this, right? Janessa, is it VI or VF? Yes, it's the initial velocity. It's how fast it's moving at the beginning of this problem. Anybody want to tell me what VF is? Do we have that value here? Yeah? What is it, Joe? 0, right. It comes to a stop, right? It's brought to rest. So VF would be 0 meters per second. My time is 8 seconds. Okay, we want to find the displacement. So we go back to our group B equations. We know that's what we do here. Okay, we know we use group B. Okay, we identify that because it involves acceleration. Let's see which one fits best now. Remember, we got VI, we got VF, we got T, we want to find D. Which of my group B equations looks like it might fit those givens best? Okay, give me an answer. If you're not right, that's okay. As long as you pick from group B, you're not going to be wrong. You may not be right, but you're not going to be wrong. Which one do you want to try first? From our group B category. Which one do you want to try first? think you're right, yeah. Let's number these actually. Let's call this 1, 2, 3, 4, 5, and 6. You just said number 6. Okay, let's give that a try. Looks like it fits those givens pretty well. D is equal to VI plus VF over 2 times T. Okay, we've got VI at 16 plus 0 divided by 2 times a time here of 8.0 seconds. 16 divided by 2 is 8, times 8 is 64 meters. Okay, so we got it on the very first try. What if we had picked another one? What if we had picked VF squared is equal to VI squared plus 2AD? Is that a wrong equation? Is that an equation that's not valid? Not at all. Okay, it's a group B equation. We're allowed to try any of the group B equations. Let's see what comes out of this here. Okay, we've got VF, we've got VI, we don't have A, and we don't have D. Are we able to solve for D using that equation? And we can't because we have two unknowns. Did we get the wrong answer? No. We just have two unknowns, so we don't get an answer. Okay, let's try again. If you try that equation, that's okay. Try another one. Eventually, there's only 5 of them, right? Eventually, you're going to find the one that works. Let's take a look at these two questions on page 48, please, okay? So work on these for about 6 or 7 minutes at your desk. Put up your hand if you're having trouble with them. Okay, after that 6 or 7 minutes, we'll take a look at 1 or 2 of them if we need to, okay? All right, if we have no issues with those two questions, let's take a look at another example, 1.14 on page 50, please. We're going to do lots of these acceleration problems because they're important. Okay, they, along with V equals D over T, lay a pretty strong foundation for us for the rest of Physics 20 and, for that matter, a large part of Physics 30. They're really important. A golf ball that is initially traveling at 25 meters per second hits a sand trap, slows down with an acceleration of negative 20 meters per second squared. Find its displacement after 2 seconds. Is this a group A problem or a group B problem? Does it involve constant velocity or acceleration? I think this one should be pretty clear on that. Constant velocity or acceleration? What do you say to that? Thomas, what do you say? Is it constant velocity or acceleration in that question? Yeah, it tells me it's an acceleration of negative 20. What does that negative 20 mean, by the way? What is it, Jazzy? Yeah, it's slowing down. If it's a negative 20 meters per second, it means it's slowing down at a rate of 20 meters per second. In the end, a deceleration of 20 meters per second is the same as an acceleration in the opposite direction. If I decelerate to the right, that's the same thing as accelerating to the left. Either one of those give you a negative acceleration. It's a group B problem. Let's write down some givens here now. Something is 25 meters per second. Clearly that's going to be a velocity. Is it going to be a VI or a VF? Shouldn't be very hard with the wording of this question. A golf ball that is initially traveling at 25 meters per second. Jordan, is that VI or VF? A golf ball that is initially traveling at 25 meters per second. Good. VI is 25. Good. Hits a sand trap and slows down with an acceleration of negative 20. Something is negative 20 meters per second squared. Tell me what that is. Is that VF? Is that A? Is that T? What is that 20 meters per second squared? Dustin, what is it? Good. A is negative 20. Don't forget the negative. Don't drop the negative. Okay, we have a time here of 2 seconds. We want to find the displacement delta D. We established that this is a group B problem. It involves one of those 5 acceleration equations. Which one of those 5 do you want to try here? We have VI, we have A, we have T, we have D. Which of these 5 do you want to try first? Keep in mind, nothing within group B will give you the wrong answer. It's just that one of them will give you the right answer. Which one do you want to try? Okay, so the third one there. Okay, let's give it a try. Okay, whether you're right or wrong, doesn't really matter because it's a valid equation. You're not going to get the wrong answer with that equation. Worst case scenario, it just doesn't give you an answer. You have to try again. D is equal to VIT plus 1/2 AT squared. D, we don't know. We're looking for that. That's good. VI is 25. T is 2 seconds. Okay, it's looking good here for us. 2 seconds. We add that to 1/2 of neg 20 times 2 seconds squared. Let's do this in separate steps here. 25 times 2 is 50. 1/2 of neg 20 times 2 squared. 2 squared is 4. 4 times 20 is 80. Half of that is 40. But it's going to be a negative 40 because it's 1/2 of neg 20 times 2 squared. What's 40 plus neg, sorry, what's 50 plus neg 40? 50 plus neg 40, come on, you guys. 10. So the answer to this question is 10 meters. We got a positive answer. What does that tell us about the direction of motion? If it was moving to the right, then the displacement is to the right. And that should be pretty intuitive, right? If it's moving in one direction, its displacement will be in that direction. You can't move to the left, but yet have a displacement to the right. All right, let's take a look at these two questions, please, on page 50 that go along with that one. All right, everyone, we're going to take a look at question number 2 here now. That seems to be the one that's given people a little bit of trouble. It says, a motorcycle traveling at 100 kilometers per hour on a flat road applies the brakes at 0.80 meters per second squared for 1 minute. How far did the motorcycle travel during this time? Well, there's a couple of things that we've got to spot here. Okay, besides the fact that this is a group B problem. We know it's group B because it's slowing down. Jordan, put it away, please. It's a group B problem because it's slowing down. But there's a couple other things that we got to spot as well. The first thing is that we've got kilometers per hour and minutes. We don't want those. Okay, we want meters per second and seconds. Whenever you're dealing with acceleration, you must be in meters and you must be in seconds. So this is not what we want. The other thing is this, and I don't know how many of you caught this. This 0.80 meters per second squared, it's slowing down at that rate. So that value is actually what? Not 0.8, but rather, yeah, we're going to make it a negative value. When something's slowing down, let's make that acceleration a negative value. So let's write down our givens now. We know that VI, the initial velocity, this is before the problem began, was 100 kilometers per hour. We will convert that to meters per second in a moment. Okay, but we'll leave it there for now. It applies the brakes at 0.80 meters per second squared. That's going to be acceleration, but remember it's going to be negative 0.80 because the brakes are slowing the car down or the motorcycle down. The time here is 1 minute. We got to convert that to seconds as well. That's an easy one, so I'm just going to convert that right now in my head. 1 minute is equal to 60 seconds. And we want to find out how far it goes. Let's do the conversion up here right now before we go any further. 100 kilometers is the same as 100,000 meters. Now, that's not 100,000 meters per second, though. It's 100,000 meters per hour. 1 hour is 3,600 seconds. 100,000 divided by 3,600 is somewhere, I think, in the range of 27.7778 meters per second. Multiply by 1,000 to get meters, divide it by 3,600 to get meters per second. Now, which equation do you want to use given that you're looking for D, you've got VI, you've got A, and you've got T? Which one do you want to try here? Ryan, an idea for this one? Pick one. It's a group B problem. Pick one. Which one? Okay. VIT plus 1/2 AT squared? Yeah. It doesn't matter what number it is. In fact, tomorrow when I write them down, I'll probably write them down in a different order, so they'll be numbered differently, right? VIT plus 1/2 AT squared. Let's give it a try. If it doesn't work, then we'll try again. We know it's valid. We know we're not going to get the wrong answer. Worst case scenario is we just don't get an answer because we have too many unknowns. VI is 27.7778 meters per second. Let's leave it to 4 or 5 decimal places because it's not a final answer. T is 60 seconds. Half of negative 0.80 times 60 seconds squared. Okay, let's do this on our calculators to make sure that you guys can get the right answers here. Say 27.7777 times 60 gives me 1666.666. Now we're going to say 0.5 times negative 0.8 times 60. Don't forget to square that. Gives me negative 1440. So it's 1666 minus 1440. And when we do the math on that, it works out to be 226.7, or 2.3 times 10 to the 2 meters. We actually should round it to 2 digits here because of our givens. 3 digits, 2 digits, 2 digits. Final answer has 2 digits. Okay, how many people got that one? 2.3 times 10 to the 2, or 226, or whatever. Good, good. Okay, a couple big things there, right? The units, we want to be in meters and seconds whenever we're dealing with acceleration. Okay, and secondly, we got to make sure that we make that 0.80 meters per second negative because it's to the left. Okay, to the left, it's a deceleration, which means it's the same thing as an acceleration to the left. All right, let's try one more problem today, and then we'll wrap it up for the day here, okay? This one's 1.15 on page 51. Speedboat slows down at a rate of 5.0 meters per second squared and comes to a stop. The process took 15 seconds. What's the displacement of the boat? Group A, Group B. Okay, we're not worrying about givens yet until we establish what kind of a problem this is. Group A or Group B? Is it constant velocity or is it speeding up or slowing down? Speeding up, slowing down, right? Specifically slowing down. So that makes it what kind of a problem, Group A or Group B? James, is it Group A or Group B? Yeah, it's Group B. Okay, it's an acceleration problem or specifically a deceleration problem. So write down those givens. A is what? 5? Is that right? 5.0 meters per second squared. Time is 15 seconds. Want to find D? Is there anything else we have here? If we read between the lines, there is one more thing, Liam, that's given to us. Jazzy? Good, excellent. VF would be 0 meters per second because it comes to a stop. Now, there's a mistake here as well. A small mistake, but an important one. What is it? Yeah. Whenever it's slowing down, the acceleration has to be negative. So let's make this negative 5 meters per second squared. Okay, don't automatically make it negative, only if it's slowing down. Okay, but that's what it's doing here. Now we've got VF, A, T, we're looking for D. Which one do we want to try here? We've got VF, we've got A, we've got T, we're looking for D. Equation 2, 3, 4, 5. I eliminated 1, right? Because it's a group A problem, a group A equation. Of the group B's, equation 2, 3, 4, 5, 6. Which one do you want to try here? Spencer, you got an idea for that one? Try 4, VFT minus 1 FAT squared. Okay, I think you're right on that. Let's give it a try. If you're not, then we'll try again. VFT minus 1/2 AT squared. VF is 0. What's 0 times 15? We know this one. I hope we do. 0 times 15 is, well, we better know that. 0 times 15 is 0. So I'm just going to put in the term 0 right there, right? A is -5. T is 15. Don't forget to square that. 15 squared is 225. 225 times 5 is, I think, 1125 times a half is 562.5. Is that right? Which would round to give me 5.6 times 10 to the 2 meters. Hey, how did I get a positive number there? Is that right? William, is there a mistake there? What was your question? Okay, good question. That's exactly what I was just asking, actually. Why is it a positive number? Why do we get a positive value out of that? Go ahead. Yeah, negative times a negative gives me a positive. And intuitively, we should recognize, we should predict a positive answer, right? Listen, it's moving to the right. What's the displacement going to be? To the right. You can't be moving in the positive direction, but yet get a negative displacement. We should expect a positive displacement because the velocity was positive, not because the acceleration was positive, because the velocity was positive. The displacement has to be in the same direction as the velocity, right? Okay, write that down if you haven't already. All right, let's take a look at these two questions to finish it off for the day here, please. 51, number 1 and 2. And those are homework for tomorrow in addition to quiz number 3 on acceleration. All right, that's it for today.